Good morning, children. Let's continue with chapter 10, circles. Today's first topic is circle through 3 points. Let's see how many circles are possible through a given point P, through 2 points P and Q, and then we'll discuss about circle through 3 points. Given a point P, you can draw as many circles passing through that point P. That is, infinite number of circles are possible through a given point P. Similarly, infinite number of circles passes through 2 given points P also. With a different radii, you can draw as many circles passing through 2 points P and Q. But when you are given 3 collinear points P, Q and R, if you draw a circle through P and Q, definitely the point R will lie outside the circle, or if we draw through P and R, a circle through P and R, definitely the point Q will lie inside the circle. That is, if 3 points are collinear, we can draw only circles through 2 given points, and the third point can be either inside the circle or it will lie outside the circle. What will happen when the 3 points P, Q, R are non-collinear is, you imagine P, Q, R are 3 non-collinear points. If you join PQ and construct its perpendicular bisector, if you join QR and construct its perpendicular bisector, the 2 perpendicular bisector will meet at a point, and with that particular point as center and radius equal to OR, if you draw a circle, it definitely passes through all the 3 points. This is a very important property, that there is one and only one circle passing through 3 non-collinear points. That is, if you are given 3 non-collinear points, there is only one circle passing through those 3 points. The pictures can be very well understood by referring to page number 174 and 175 of your textbook, figures 10.17. Refer to figure 10.17, 10.18 and 10.19. The explanation can be clear by referring to these pictures in your textbook, page number 174 and 175. Exercise 10.3, question number 1. Draw different pairs of circles. How many points does each pair have in common? What is the maximum number of common points? Here, this question you can take it in 2 different concepts. How many points does each pair have in common? If it is how many intersection points, or simply how many points. If it is intersection points, if you draw the circle, one pair of circle which do not touch or intersect each other, no points in, no intersection points in common. No intersection point in common. Suppose you just draw 2 circles exactly touching at one point. You can say one point of intersection, or it is the point of contact. And if you draw another pair intersecting, then it has two intersection points. Intersection points A and B. But if we simply consider how many points does each pair have in common, if you draw one circle within another circle, you can say there can be infinite number of points in common. If it is intersection points, if it is maximum number of intersection points for a pair of circle is 2. But if it is simply point of points in common, it can be infinite if you consider the figure in this particular form. Question number 2. Suppose you are given a circle, give a construction to find its center. You are given a circle, which shows that given a circle, how do you find the center of this circle? As I said, given a circle, to find the center O. So the method is take 3 non-collinear points on the circle. Let's take it as A, B and C. Join AB, construct its perpendicular bisector. Join AB, perpendicular bisector with A as center and the radius more than half of AB, cut 2 arcs, with B as center and with the same radius, cut 2 arcs, and if you join that particular 2 arcs meeting point, that will give you the perpendicular bisector of AB. Similarly, join BC, construct its perpendicular bisector, join BC, construct its perpendicular bisector. It will meet the perpendicular bisector of AB at O. Both the perpendicular bisectors will meet and that meeting point will give you the center of the circle. We meet at O, which is the required center of the circle. And this question is based on there is only one and only one circle passing through 3 non-collinear points. So the best way of finding the center of a circle is to plot 3 non-collinear points. You can also say that draw a chord, draw its perpendicular bisector, draw the second chord, draw its perpendicular bisectors. Where the perpendicular bisectors meet, that will represent the center of the circle. Question number 3. If 2 circles intersect at 2 points, prove that their centers lie on the perpendicular bisector of the common chord. Mark it as a very important question, or you can also study it as a property. If 2 circles intersect at 2 points, prove that their centers lie on the perpendicular bisector of the common chord. Let's draw 2 circles with center O and O dash. So given 2 circles with center O and O dash, and intersecting at A and B. What is to prove is OO dash. What is to prove that OO dash is the perpendicular bisector of AB. Let's take this point as M. As construction, you can join OA, OB, O dash A and O dash B. Join OA, OB, O dash A and O dash B. The proof starts with proving the congruence of triangles OA, O dash and OB, O dash. In triangles OA, O dash and OB, O dash, OA equal to OB, radius of the same circle. Similarly, O dash A is equal to O dash B, radius of same circles. OO dash is equal to OO dash common. Therefore, triangle OAO dash congruent to triangle OBO dash by SSS. We can take angle 1 is equal to angle 2 as CPCT. The second part of the proof is to prove triangles OMA congruent to triangle OMB. In triangles OMA and OMB, the first equal parts OA and OB. The second part angle 1 is equal to angle 2 proved. And OM is equal to OM common. Therefore, triangle OMA is congruent to triangle OMB by side, angle, side. That is by SAS congruency. So, what are the CPCTs? The first one, AM is equal to MB CPCT, which shows that it's a bisector. Also, angle 3 is equal to angle 4. And now, angle 3 plus angle 4 is equal to 180. Linear pair. By that, since both angle 3 and angle 4 are equal, therefore 3 is equal to 4 is equal to 90 degree. From AM is equal to MB as well as 3 is equal to 4 is equal to 90 degree, we can prove that OO dash is the perpendicular bisector of AB. That is, OO dash is the perpendicular bisector of AB. This particular concept, you can learn it as a property. That is, if two circles intersect at 2 points, then the line segment joining the centers will always be the perpendicular bisector of the common chord. The next topic is the distance of a line from a point. That means you are given a line represented by AB and let B be a point outside it. Since a line has infinite number of points, there can be infinite number of lines from the point P to the line AB. So, what is the concept of distance of a line from a point, or which is the line, or which line can be considered as the distance of the line from the point is, there will be a line exactly perpendicular from P to the line AB, and that perpendicular line PM will be the distance of the line from this point. The PM perpendicular to AB will be the distance of the line AB from P. Whatever be the length of the line segment PM, which is the perpendicular, that will be the distance of the point B from the line. The next property of chord is based on the particular concept explained, that is the distance of a point from a line, or how can you measure the distance of a line from a given point. The property says that equal chords of a circle are equidistant from the center of a circle, which shows that you are given a circle and two chords AB and CD which are equal. So, given AB and CD are equal chords. Now, equal chords are equidistant from the center. If you compare the property explained, the distance of line AB from point O is the perpendicular distance OM, and the distance of line CD, or distance of the point O from line CD, is the perpendicular distance ON. So, OM perpendicular to AB and ON perpendicular to CD are the perpendicular distances from O to AB and CD. What will be the relation between OM and ON is OM, therefore OM will be equal to ON. That is, if AB and CD are equal chords and OM perpendicular to AB and ON perpendicular to CD, then automatically the length of OM and ON also will be equal. That is the meaning of this particular property. That is, equal chords are equidistant from the center of the circle. What will be the converse statement? The converse statement will be chords which are equidistant, chords which are equidistant from the center are equal. In a circle, chords which are equidistant from the center are equal. The meaning is, given two chords AB and CD, AB and CD are two chords, then OM perpendicular to AB, OM perpendicular to AB and ON perpendicular to CD, such that those distances are equal, means OM and ON are equal. Then if you measure AB and CD, they also will be equal. Then AB equal to CD also. That is, if AB and CD are two chords, OM perpendicular to AB and ON perpendicular to CD, such that OM is equal to ON, then automatically AB and CD also will be equal. That is the meaning of the statement. Chords which are equidistant from the center are equal. So there were three properties. The first property, equal chords subtend equal angles at the center of the circle. Then a perpendicular from the center always bisects the chord. And the third property, equal chords are equidistant from the center of the circle. Exercise 10.4, question number 1. Two circles of radii 5 cm and 3 cm intersect at 2 points and the distance between their centers is 4 cm. Find the length of the common chord. So, let O represents the center of the circle with radius 5 cm. We need to draw a circle of radius 3 cm. At the same time, the distance between the centers is only 4 cm. which is very clearly understood that the center of the second circle O dash will lie inside the first circle, as the radius of the first circle is 5 centimeter. This distance is given as 4 centimeter. AB is the common chord. If you join OA, that is 5, O dash A is 3 centimeter. And now, what is to find is the length of AB. So, OA is equal to 5 centimeter, O dash is equal to 4 centimeter, O dash A is equal to 3 centimeter. By the last property, we explained if two circles intersect at 2 points, then the line segment joining the centers is the perpendicular bisector of the common chord. Here, AB represents the common chord and O dash is the perpendicular bisector of AB, which shows that the length of AB is 3 into 2, that is 6 centimeter. So you can give the reason as, since the two circles intersect at 2 points, the line segment joining their centers is the perpendicular bisector of the common chord. And here O dash A is 3 centimeter, therefore AB is equal to O dash A into 2, that is 3 into 2 or 6 centimeter. So the length of AB is 6 centimeter. Question 2. If two equal chords of a circle intersect within the circle, prove that the segments of one chord are equal to the corresponding segments of the other chord. If two equal chords of a circle. So given that AB and CD are equal and at the same time they intersect at the point P within the circle. And what is to prove is, prove that the segments of one chord are equal to the corresponding segments of the other chord. What we have to prove is PA is equal to PC and PB is equal to PD. PA is equal to PC and PB is equal to PD. Let OM perpendicular to AB represents the distance of O from AB and ON perpendicular to CD. So, as construction, let OM perpendicular to AB and ON perpendicular to CD and join OP. The first part of the proof is to prove triangle OMP congruent to triangle ONP. Proof: in triangles OMP and ONP, OM is equal to ON. The reason is equal chords are equidistant from the center of the circle. From the center of the circle, angle 1 is equal to angle 2 is equal to 90 degree. And the third part, OP is equal to OP common. Therefore, triangle OMP is congruent to triangle ONP by right angle, hypotenuse, side. That is by RHS congruency. And what is the CPCT? MP is equal to NP. Therefore, MP is equal to NP is the corresponding parts of congruent triangles. Now, what is the relation between AB and CD? AB is equal to CD. So, what is half AB is equal to half CD? Half AB can be either AM or MB. That is, MB is equal to half CD can be either CN or DN. I can take it as DN. Perpendicular from center bisects the chord. Now, MP is equal to NP. Along with MP, if you can add BM, it will be BP. Along with NP, if you can add ND, it will be the part DP. So, MP plus MB is the same as NP plus DN, or once again, MP plus BM is the same as BP is equal to NP plus DN is the same as DP. And now AB and CD are equal. If you subtract this results, AB minus BP is the same as CD minus DP. You will be getting the remaining segments. What is total of AB minus BP is giving you AP, and CD minus DP is giving you CP. So, if two equal chords intersect within the circle, the length of the segments of one chord are equal to the corresponding segments of the other chord. Question number 3. If two equal chords of a circle intersect within the circle, prove that the line joining the point of intersection to the center make equal angles with the chords. The line joining the point of intersection with the center make equal angle with the chords. That means what we have to prove is angle 1 is equal to angle 2 in this particular figure. That means given AB and CD are two equal chords, they intersect at the point P. O represents a circle. What is to prove is angle 1 is equal to angle 2. So like as in the previous problem, let OM perpendicular to AB and ON perpendicular to CD be the distances of the point O from AB and CD. What is to prove is angle 1 is equal to angle 2. Construction. Draw OM perpendicular to AB and ON perpendicular to CD. Just prove the triangles are congruent. In triangles OMP and ONP, OM is equal to ON, the same property, equal chords are equidistant from the center of the circle. From the center of the circle, then OP is equal to OP common, angle OMP is equal to angle ONP is equal to 90 degree. Therefore, triangle OMP congruent to triangle ONP by right angle, hypotenuse and then side by RHS. Therefore, angle 1 is equal to angle 2, or angle MPO is equal to angle NPO. The line joining the center and the intersection point make equal angles with the chord. The remaining questions we will do in the next class.